Hello everyone, hope you're doing good. Welcome back to my channel. Today we're at day 30 of the January daily Leetcode challenge. This will be the second last day to complete this question. The weekend is near and this is the correct time for facing some of the hard questions. Okay, that's what Leetcode says. And we again have a hard question today. And let me tell you, this question will be eye opener for you. A lot of people will claim a lot of things about this question, but I will tell you very frank thing. Only if you know BFS, okay, or at least DFS. I meant only the traversal algorithms. If you know only the traversal algorithms, you can solve this question, and I will prove that. Okay, you don't need to know all those bipartite graph or the union final algorithm or anything like that. Just with a simple BFS you can solve this question, and I will prove the same today. Okay, so let us begin with this question, and let me tell this very frankly, though it is marked as a hard question, it is going to be very very simple. I will show you my solution, guys. Like, I've done a lot of work today to bring a lot of content for you. Okay, I've even brought these things like how to optimize like how to visualize the graph and all that. So this thing also may be helpful for you in order to understand the examples. So I've done a lot of homework, friends. So just watch this video completely, and I'm sure that you will this will be useful for you. Okay? I've done a lot of groundwork so that you get the most ultimate solution, that everything in this question is clear to you after watching this video, right? So yeah, coming to today's question, we will be solving this hard question with only a simple basic algorithms about graph, and I will be using BFS for this code. Okay, see, a lot of people, if you see like go elsewhere, you will see that a lot of people are claiming a lot of things about this question. They'll say that you have to know the bipartite graph algorithms, that is what is the definition of a bipartite graph and all that. See, if even if you see the hints, basically you'll get to know that. See the first hint, they are saying something about bipartite. Okay, you can learn about these things, but I will tell you the same. These things are not needed as such to solve this kind of questions. Okay, these are like some additional concepts. Like, see, this is actually not algorithm, this is a graph concept. So if when you learn graph, okay, in your engineering or maybe in your whenever you're studying about graphs, you will get to know about these things. Okay, so but yeah, if you know this concept, it's good, but this is not needed to solve this question, and I'll prove the same with a simple BFS. I will solve this question, right? Let's begin. So it is question 2493. Divide nodes into the maximum number of groups. Okay, this, if you get this kind of question in a contest, in a LeetCode contest, this will be the question number 4. Okay, always the hard question will be question number 4 in LeetCode. Okay, most of the time, right? And even question 3 sometimes hard question, but yeah, this is the question level 4. So if you are able to solve this kind of questions, you should be able to clear all the 4 questions in a contest. Okay, that is something that should be targeting, right? Now, what we're given, so it's very simple. As I mentioned, it's a graph question, so we'll be given edges of a graph. Okay, so these are the edges, and let me tell you this is not a directed graph. That means, like, both ways you can traverse. For example, if you see the first edge, it is from 1 to 2. Okay, that means you can go either way. You can go from 2 to 1, or you can go from 1 to 2. Okay, these are not directional ones, and this will give you how many nodes are there. Okay, in this, if you see, there are 6 nodes, and the nodes are starting from 1 till n. Okay, that means node number 1, 2, 3, 4, 5, and 6. Okay, they are not starting from 0. So this is the convention that they are following, right? Now, what you have to return, so what you will have to return is, see, as you can see, there are some diagrams being formed here. So what they're trying to tell you is that you will have to return me the maximum number of groups for each connected component. So friends, see, like, I spent a lot of time in this question. So whenever I'm saying something, it definitely has a meaning. So if you're not able to understand the first group, please do not worry. You always have an option to pause the video and like go back and see that again. Okay. So what I meant to say is, see, it's all about how many maximum groups that we can form for each connected component. Okay, what is a component and what are connected, like, all these things will come now, but just understand this, I'm just giving you a hint of the whole question, so that when you read that text, you have something in your mind, like what is happening, you can like visualize that. Okay, always, that's why in my videos I will show you the input as much as possible. I will try to explain with the input itself, and then we'll go to the text. Okay, so this is the question. Now let us begin with the question. You are given a positive integer n representing the number of nodes in an undirected graph. Okay, it's very clearly mentioned it's undirected one, so the same will have to, see, if you confused here itself, the question is over. Okay, it is undirected graph, either ways you can travel for each of the edge. Okay, the node are labeled 1 to 1. This thing I've already mentioned. You are also given a 2D integer array edges, where edges of I is equal to ai comma bi. That means they are trying to tell that is the edge between ai and bi. Okay, indicates that there is a bidirectional edge between nodes ai and bi. Notice that the edge graph, the given graph, may be disconnected. What it means, remember, this is again very important. If you're not able to decode what is the meaning of disconnected, again the question is over for you. Cannot complete this question in any way. Okay, so what it means, see, and let me tell you this, the way they have given these examples, that this part will not be clear to you. Okay, so what you can think of is, see, I will tell you the thing. Go to example number 1. Okay, just go to example just a second. Yeah, just go to example number 1, and instead of 6, try to give the input as 7. Okay, same thing I've done. This edges remains the same, whatever is there in example number 1. Only difference I've created is you have to add additional edge. That is from 6, you will have to make it to 7. I mean, you have to add additional node. So what will happen is the node number 7, if you see, it is not connected to any other node. So you have to just imagine like there is a node 7 here, but it is not connected to any other component because it is not mentioned any of the edges. Okay. Now, if you try your code, it should work. Okay, that is the basic idea. So what is a connected component? Connected component means that component is connected to some other node through edge. Okay, that is, that node is connected to the main graph through edge. But what is isolated node? That means it is not connected to the main graph. Okay, so that's what they're trying to tell you through this. Okay, so when they say this, that means that the whole graph, okay, that is the whole the thing that we're seeing here may not be a single one. That is, there could be sub graphs elsewhere, okay, but they're not connected to the main graph. Okay, for example, let's say there are nodes 7 and 8, but they are not connected to any of the nodes 1 to 6. Okay, but 7 and 8 have edge, but they're not connected to the main graph. Okay, so 7 and 8 will form a separate subgraph, and similarly 1 to 6 will be a separate subgraph. Okay, that together will form a total graph, but remember, still they will not be connected. But we'll say that yeah, they are part of the same question, but still they will not be connected. So I hope now you understand what is the meaning of a disconnected graph. It means it will have several subgraphs, and those subgraphs will not be connected with each other. So what I mean to say is that you will have to process you have to write a code in such a way that each node is visited, and we try to find out whether they are connected to somewhere or not. So what I mean to say is, for example, see, let us say I have a node 7 and 8 and they are connected, but they're not connected to 1 to 6. Okay, so let us say you start your processing from node number 1, so you will never reach 7 8 because they're not connected to node number 1 in any way, right? So that is how you have to process it. Okay, just about how you're processing. Okay, that's what, nothing else, right? Just that is what. Now, so we have completed till here. Next, let's see, divide. Okay, now comes the most important one. Please pay attention now. See, divide the nodes of the graph into m groups. Okay, one indexed, such that, see, they are like m indexed means, sorry, m groups means like that. Okay, each group that you're seeing, right? The green color rectangle, the blue color rectangle, they are called groups, right? Now, each node in the graph belongs to exactly one group. So idea here is every node has to be part of one group. They more than one group, it cannot be present. Okay, as simple as that. For every pair of nodes in a graph that are connected by edge, okay, that is, let us say ai and bi are connected by edge. If ai belongs to the group x and bi belongs to the group y, then that modulo difference of them should be 1. What that trying to tell you is that, see, for example, so in the given example, if you see, the node number 5 is in group 1 and node number 1 is in group 2, and they have edge. So if I subtract 2 and 1, because see, 1 is present in group number 2, 5 is present in group number 1. So if I subtract 2 and 1, I will get 1. So this satisfies this condition. Okay, if I subtract the groups, remember y and x are groups. They are not the node number, they are the group number. Okay, so if I subtract y and x, I will get answer is 1. Okay, as simple as that. And similarly, let us see some more cases. For example, 2 and 6. Okay, 2 is present in group 3, 6 is present in group 4. So if I subtract 4 and 3, because there is edge between these two nodes, okay, 2 and 6 have edge, so I should subtract their groups. So group 4 minus group, that is 4 minus 3 is 1 again. So again, this satisfies this condition. Okay, so that is what they are trying to tell you. For every pair of nodes in a graph that are connected by an edge, if ai belongs to the group x and bi belongs to the group y, then the modular difference of them should be equal to 1. Okay, as simple as that. If that is not the case, then you will have to return -1. That's what they're going to tell now. Return the maximum number of groups, that is maximum m, into which you can divide the blocks. Okay. Return -1 if it is impossible to group the nodes with the given conditions. Let us start to analyze some of the things. See, it's very clear now. For example, if there is edge between 2 and 4, can you quickly tell me what will happen? With if you introduce edge between 2 and 4, the answer will be -1 by, see, group 2 is supposed to be 1 plus, see, 2 is connected to 1. Okay, similarly 4 is connected to 1. So whatever be the group of the node number 1, you have to do +1 to get the group for node number 2 and 4. Okay, so group 2 will be, sorry, the node number 2 will have group 3, node number 4 will have group 3 again. Okay, now if you connect them, what will happen? If you connect them, there is an edge between 2 and 4, so node number 4 should now have a group which is +1 of group number 2. Okay, but that is not the case. Both of them are in the same group. Okay, that's why it will be false. Okay, no problem. I'm sure you have not understood that. Come to this example. That's why I've created this diagram separately. So you can also like try this. Okay, I will give this link maybe in your comment section. You can also come here and you can give simple inputs like this, and this will generate a graph for you, right? So let me explain with this. So if you are if you are seeing the example number 2, what will happen is I will tell you why the answer is coming -1. Okay, see this case. Yeah. So see this part. Let us say you are here. Okay, you are in node number 1. You're starting from node number 1. Okay, so node number 1 is in group 1. Similarly, node number 2 is in group 2. Now, node number 3 should be in group 3, but node number 3 is also connected to node number 1. So there is a conflict now. Either node number 3 should be in group 2 or node number 3 should be in group 3. There are two cases now coming, okay? But if you see that, that is not allowed, right? Each node is supposed to be in exactly one group, and always in every possible instance for every edge, basically, if you subtract the nodes of the corresponding nodes, if you subtract the groups of the corresponding nodes, it has to give one, okay? But that is not the case here, okay? See, if we start from 1, then both 2 and 3 are supposed to be in the same group, basically, okay? But if you see, if you start from 2, that is, if you come to 2 and then go to 3, then both of them are supposed to be in the same different groups. So for that reason, the answer you have written is -1, because it is not possible, basically, it is not possible to group the nodes with the given conditions, okay? As simple as that. So I hope you now understood. That's why if you'll see, like in the hint, that's why they have mentioned this topic, like bipartite graph. So what that means is, basically, every edge, basically, if you see, let's say it connects x and y, so x, all the x, basically, that is all the nodes from which the graph from the which the edge starts, they x, for all x and all y, there should be different groups, okay? As simple, that's what they're trying to tell you, that, okay? So the idea here is, within a group there should not be edge. That is a summary of all this, okay? Now, so I will give you this link, you can go through this and try to understand. So idea is very simple. See, again, one thing, if there is edge between 2 and 4, can you quickly tell me what is happening? There is now a cycle getting created. So again, if you, in short, if you want to ask what will happen, so in short, I will say that whenever there is circle present, we will have to return -1, okay? As simple as that. That is the very basic thing, that very basic term that I can use to explain this. Whenever there is circle, you have to return -1, right? Now, how to solve this? We'll use the exact way that they have asked us to do, and let's see how it works. Yeah, and before that, I will show you some examples so that you are very clear with this topic, okay? Yep. Let us go to example 1. Example 1 is a very good one, actually, but only thing is, it is not covering the ultimate picture, like the disconnected component is not covering that, okay? Now, let me zoom out a bit so that you can get a complete thing in one go, okay? Yeah. If you see now, see, I have, pasted different. Let us say you start BFS from the node number 1. So what will happen? You will get that maximum groups equal to string. Why? Let us see. If you start on node number 1, so node 1 will be in group number 1, okay? And node 2, 4, and 5. See, please start to imagine what is happening. Node number 1 will be in group 1. All the nodes which are connected to 1, okay, that is 2, 4, and 5. They will be in group number 2. And similarly, all the nodes which are a distant 2 from group number 1, they'll be in node 3. Okay, so at max we'll get 3. Okay, if you see, number 1 is in group 1, node number 2, 4, and 5 are in group 2, and 6 and 3 are in group 3. Okay, now same thing here. If you go with BFS of node number 2, you can go through the rails, like, see, that's why giving you these things. You can always understand what is happening. But again, I will directly come to the case. See, there are difference coming. Maximum groups, if you do a BFS in node number 1, you will get 3. If you use node number 2 BFS, you will get maximum group equal to 3. But if you use BFS for node number 3, 4, 5, see, in this example they've given node number 5 is the starting root, okay? So if you do a BFS with node number 5, you are going to get maximum groups equal to 4, okay? And that is what we are going to take as the answer, okay? So if you start with node number 5, what is happening? See, always node number 5 in group 1. Next node, that is, see, it's all BFS means, try to imagine like how the level wise. That's why if you know the graph, the tree algorithms, this question will be easier for you. See, what is happening is, we have to go level wise. That is, all the nodes which are distance 1 from the root will be having a group number 2, or the nodes which are distance 2 from the root will be plus 2 of the group number of the root, and so on, okay? So 5 is in root 1 is root, so it's group 1. 1 is, it is a distance 1, so it is group 1 plus 1, which is group 2. Similarly, if you see 2 and 4, they are at a distance 2 from the root, so it will be group 1 plus 2, which is group 3, and so on, okay? So in this case, we are getting max group equal to 4 in any of the BFS, okay? We have to remember, we have to do BFS by taking each of the nodes as a starting node. In that case, we'll get max group equals to 4, okay? So that is what is the answer, and we will show that is the answer. But in my case, like in my, see, again, you will ask me how to know that. See, for example, as I mentioned, the graphs can be disconnected. So how do I know, like, which BFS is giving which result, and how to, like, save them and compare them to get the maximum? So idea is very simple. In my case, what I will do is, see, in a connected component, the leader will be the smallest node in that. In this case, if you see, node number 1 is the smallest node. That is, it's the node of the smallest value. I mean, the exact number, like n is 6, right? So in this case, this n for this is 1, okay? So this node number 1 is the smallest value. So that I will elect as the leader, and that will be showing us what is the max number of groups that can be formed, okay? Remember, it doesn't mean we have done BFS from 1. It just means that the max value we can get in the connected component for which 1 is leader is 4, okay? As simple as that. So that is the idea that I'm going to use, okay? Let me show the code now, okay? Now, so among all the nodes in a connected component, smallest node will be the leader, and that will, in this, if you see, finally, that will tell me, the leader, the value of the leader will tell me what is the maximum number of groups that we can get in that particular connected component, okay? Now, I've created two data structures. One is the group count map. Okay, this is what I printed at last. Okay, this is what I printed at last, and this is what you saw just now. Okay, this is what you saw just now. Okay, this is the one, right? Yep. Next is, yeah, graph. This is the graph itself. Like, we'll capture the edges here. So this is the basic default graph. If you see, the values are going to be integer here, the values are going to be a list here. Okay, now first of all I will capture the edges. Okay, what I will do, see this part, I will go through for I comma j and edges. What I will do is graph of I dot append j, similarly graph of j dot append I, because they are like bidirectional, so I have to append in both way. So I will be a, okay, adjacent for j, and similarly j will be adjacent for I. Okay, and so on. Right, now I will explain the what is the BFS function. Okay, then we'll go to the case. Okay, now see, so this is how I'm going to trigger the BFS. See, I'm going through each node from 1 till n, and then I'm triggering BFS for each one of them. Okay, now what will happen, see this case. So as I mentioned, like, see, if you do BFS from different nodes, what will happen is you will get different answers. But how do you know, like, for this connected component, this is the answer? That's why we are using this. See, for each connected component, if you see, the leader will be the smallest value node present that. Okay, so through that we'll get to know what is the previous value we have got, what is the previous max value of groups we have got here, and similarly we'll compare and record the max value. Okay, as simple as that. So this is a BFS function. So if you see, I've taken non-local graph and count group map. So these are the two that we are taking inside this graph. Okay, graph and group count map. Next, I'm creating a queue. In this case, it is a DQ. What is a DQ? DQ means a double-sided queue. Okay, we will be appending from the right and we'll be popping from the left. Okay, for that reason, you can even take a simple queue if you want, but I have taken a double-sided queue. So, and this is the group map. So within this BFS, I'm in the local, I'm using a group map. I will tell you like what it means. This result, what you're seeing, right? This result, what we're seeing, this is the result of that group map. Okay, so within a BFS, we'll have a group map which will tell me for each node, okay, what was the group number of that. Okay, for example, if you see, if you do a BFS for 5, okay, that is the one diagram that you're seeing. If you do a BFS starting from 5, what you will get is, see here, 5 will have, 5 will be in group number 1. Okay, 1 and 2 will be in, okay, 1 will in group number 2. Okay, 2 and 4 will be in group number 3. As you can see, 2 and 4 are group number 3, and 6 and 3 are group number 4. That's what we are getting. Okay, that's what we're getting. So this is for that. Okay, this will in the, like, in the single BFS, in a particular BFS, what are the nodes and what are their, group values. So keys will be the nodes and the values will be the groups. Okay, simple as that. So okay, let me write it here. The keys will be the nodes. Okay, or let me write it here. So nodes and their corresponding groups. Okay, yep. So the keys are the nodes and their values are their groups. Okay, simple as that. The group number. Yep. Yep. Right. Fine. Now, since I'm starting with this particular node, so obviously this node will be in group 1. So the group map of this node is equal to 1. Okay, as simple as that. Now, one more thing, as I mentioned, for each connected component, the value, ultimately the final value will be recorded using the min node. Okay, mid node means in that connected component among all the nodes, what is the node with the smallest value. So in this case, I've elected this to store that. Okay, so currently this is the smallest node, and whenever we are getting the smallest node, we'll change that. Okay, again, and now this is the final value of that. So this max group will tell me what is the maximum groups that we can have in this connected component. Right, initially it will be 1, because for a single node also, see, connected, again, when you are having single node, again it is a group of itself, right? So this value will start with 1. Now, till the queue is not empty, we'll do this. Okay, let me just expand for that. Yeah, till the group is not empty, we'll do this. Okay, what you have to do, see, current node is equal to queue dot pop left. Okay, we are popping a node out of the queue, and current node group is equal to group map of current node. Okay, so I'm just using this, and using this I will be getting the, yeah, the group of this. Okay, remember, again, one more thing that I will tell you is that, okay, I will come to that later. Fine. See, now min node is equal to min node, that is the previous value, and comma the current value. Okay, so the current value and the previous value, whichever one is the minimum, that will be this, because finally this will be used to store the max group value that we have got for this connected component. Okay, if you see here, this is what we are doing. Okay, count group map, remember, count group map is the global one. Okay, this is the one. Okay, this is not specific to this function. Count group map is global, but okay, so this is not specific to BFS. So ultimately what we'll do is, we in this whole map, we'll use this as a key and store the max number of groups that we can get in this. Okay, as simple as that, right? So we'll come to that. Okay, so this is the, for the current node, what is the group, and then what is the, if the current node is the minimum node, or so, and similarly, if the current node group, that is this particular value, if you just compare with the max group, what if that is more than that, it will update. Okay, simple as that, right? So what we are doing for all the adjacent nodes of the current node, okay, for all the adjacent nodes of the current node, if the adjacent node is in group map, that is if it is already pushed to the queue. Okay, if it is already pushed to the queue, just compare, take the absolute value of the ground map of adjacent node minus the current node group. Okay, that is the group of the adjacent node minus group of the current node. If it is not equal to 1, remember we are taking the absolute value. If it is not equal to 1, then we'll have to return false. Okay, as simple as that. Otherwise, in all other cases, like if it is not part of the group, what you have to do, we'll have to introduce it to a group map. So group map of adjacent node is equal to current node group plus 1. Okay, always you have to do plus 1 with the current node group, and then we'll have to push to the queue. So see the order. First, we make entry of this in the group map, and then we push to the queue. Okay, if you see, we have followed the same here. First, we push it to the group, and then we make an entry of it in the group map. Okay, as simple as that. Always we have to do that. Okay, fine. Once we all this whole thing is complete, once the whole while loop is complete, what we have to do, then if you see in every loop we are updating these two fields. Okay, remember these two fields will be used here. So min node will tell me what will be the leader of this group. So if you see, this is the leader of the group, and this max group will tell me what are the max number of groups that we can reach. Okay, so this will be the one. Okay, yep. So what will happen is, see, why we are doing this is, if you see, we are doing multiple behaviors. Okay, for the same component, for the same connected component, for each of the nodes we are doing a bfs. Okay, so but for all these components, one thing that is common is their leader, because always if you see, the smallest value will be 1 in this example number 1. Always the smallest value will be 1. Okay, so with that, what we can ensure is that always for all the bfs, the result will be stored with the leader's value. Okay, for the leader 1, that is, if you see here, this is the leader 1. For that, we'll store the values here. Okay, so each, for whenever you're doing a bfs, always the value will be that they are getting. Okay, this value we are getting first. Okay, so what will happen, for 1 we'll add the value as 3. Okay, then again we are getting the value 3, and then we are getting value 4. So previous value is 3, current value is 4, so this 3 will be replaced with the 4. Okay, and but always this key, the key will be always the leader, and the value will be the max number of groups that we can get for that connected component, for which the leader is this key. Okay, that's what it is, right? Fine. And ultimately we are returning true. So see, this case, whenever we are finding a cycle, we are returning false. Okay, how to find the cycle? See, as see, in the question itself I mentioned, whenever, okay, this is not the case. See, always the modulo of that should be 1. If it is not 1, we are to return -1. Okay, that's what it is, the question, right? Same thing we are doing here. If it is not 1, okay, if it is not 1, if the modulo difference is not 1, we return false. Okay, now let's see what, how we are calling this function. Okay, so this was the bfs function, by the way. Okay, this was the bfs function. We are just passing a node to it. Okay, and for that node we are starting the bfs, right? Yeah, yeah. And see, at the end of the bfs, okay, this is something that will be updated. Okay, as simple as that. If you see, at the end of the bfs, we are updating this. Okay, as simple as that. So the value of this is equal to the previous value of this, comma, the max group that we have got for this particular leader. Okay, as simple as that. And finally we return true. So this is how I'm calling it. So see here, I'm going through each of the nodes. As I mentioned, for each node we'll start a bfs with that as the root. Okay, for the current, see, for each I going from 1 to n, okay, each I will be treated as a root for the bfs. Okay, so I'm starting a bfs, and the value returned by the bfs is captured here. Okay, so if the value returns is, if the value returned is false, we'll return -1. If the value returned is true, we'll continue with the next bfs with the next number. Okay, as simple as that. Ultimately I'm printing this, and ultimately how the get the sum will be the values of all this. Okay, the values of all the keys. Okay, so what we are doing, group con map dot values I am taking, and then taking sum of it. Okay, I will be showing multiple examples now to make this topic very clear to you. Now see here. Okay, so this was example number 1. Example number 2, again it's very clear, because of a cycle, this is returning -1. Now come to example number 3. In example number 3, what will happen is, just let me zoom out a bit. Yep, in example number 3, as I mentioned, I have just increased the n by 1. Okay, remember the edges are the same as example 1, but instead of 6 I made it as 7. So what what it ensures that there is an isolated node now. Okay, so if you see, this is the final value what we are getting for the connected component, for which node number 1 is the leader. How many maximum groups are possible? 4 maximum groups are possible. Okay, and similarly for the connected component for which group 7 is the leader, how many maximum groups are possible? 1 itself, because remember 7, it's an isolated node, so it will be a group for itself. Okay, so for the connected component for which 1 is the leader, that is the one that we're seeing in the example 1 diagram, maximum groups are 4. Similarly, for the group that is for the node itself, the node number 7 itself, it's an isolated component, and for that the number of max groups possible is 1. So answer will be 4 plus 1, which is 5. So that's why written 5. Okay, one, let's see some other case now. Same, whatever nodes at this we are seeing are exactly same, but in this case we are having n equal to 8. Okay, here n is 6, now we are having n equal to 8, but only one difference is I have added this edge separately. So this is the only separate edge. Okay, so what is happening, nodes 7 and 8 are connected with themselves, but they're not connected to the rest of the nodes. Okay, that is, there are two connected components in this graph. Okay, so one, is node number 1 to 6 are connected with each other. Node number 7 and 8 are not connected with the rest of the nodes, but they are connected in between them. Okay, there is an edge in between them. So node 7 and 8 are a separate connected component, and node 1 to 6 are a separate connected component. Okay, there are two separate connected components in this. Okay, so if you see the yep, so if you see the final answer, see here, the connected component for which node number 1 is the leader, okay, for that the max number of groups possible is 4. Okay, similarly, for the connected component for which group number 7 is the leader, the max connected component is 2, because if you see 7 and 8 are connected, okay, there is only one edge, so there are only two max groups possible. So the answer is 2 plus 4, which is 6. So 6 is the answer. Okay, as simple as that. I've captured one more example for you. Maybe I can give this in the comment section. You can try this out. Okay, this is one of the test cases which LeetCode has given. You can try this out. If you are able to get your solution, if you're making a solution clear this, then you can submit a solution ultimately. Okay, that's what I just want to tell you. Yep, this was a bigger one, so I cannot explain it directly, but as I mentioned, you can use this a link to visualize the graph if you want. Okay, as simple as that. See, often that was all for this particular video. If you talk about space and time complexity, see, it's very logical here. What we are doing for each node, we are doing a BFS. Okay, for each node we are studying BFS. So BFS will take n plus m time. What is n m? N is the number of nodes, m is the number of edges. Okay, so BFS and DFS, both of them will take n plus m time. Okay, that is number of nodes plus number of edges. Okay, now we are doing the BFS for each of the nodes. Okay, so the time complexity will be n plus m into m. Okay, n plus m into n. So this will be the time complexity. If you talk about the space complexity here, we are storing the graph. Okay, that is for each edge we are making entry. So this will be O of m. Okay, and then if you see these things, okay, for all these things at max, remember in the worst case, this can go to O of n. Okay, this can go to O of n, this can go to O of m. Okay, and in between also, if you see, for example, these things, okay, like these are like just part of a function, but still this can also go to O of n. Okay, as simple as that. So again, that will be contributing to the space complexity, but remember, this is just during a function call. This function call will end and will go to next function call. Okay, so just for a moment, yeah, this space will be occupied. Again, this is going to be O of n. Okay, as simple as that. So nodes is the key, and their values are their groups. Okay, their group number. The group number is the value for that. Okay, yep. And if you want, you can like make, so see guys, just want to tell you, so these are some of the print statements that I've enabled, but yeah, let me just cover it them out. So yeah, when you are submitting the solution, just in for understanding purpose, enable these print statements. After that, just again comment them back before submitting your solutions. Okay, yeah, that was all for today, friends. This was a hard question, and I shown you just with a simple DFS how to solve this question. Okay, and I've already submitted the solution and it worked. Okay, I will give you the link for this in the comment section for this graph. This is very like convenient to visualize a graph. You have to just see what will happen is the edges between 1 and 2, right? So you have to just pass that, and this particular one is actually the value of the node. Okay, value of the edge, weight of the edge. In our case, there is no weight as such. That's why I'm passing one for all of them. Okay, I'm passing one for all of them. Okay, as simple as that. So maybe you can try that out. So yeah, and that was all for this video. If you like my efforts, please do subscribe to the channel. This really gives a lot of motivation to continue further. So today I was a bit late in uploading this video, but I wanted to give you a very good solution. That's why when I had time, I like worked on it and created the solution, and then I showed you. I did not like compromise on the quality of the video. I took some time, but I showed you some good solutions, which I guess no one else is showing you, because everyone else is talking about the same thing: bipartite graph, union find, all that, which is already given in the LeetCode official solution. But I want to teach you something different. I want to remove your fear that, yeah, with a simple BFS, if you're very clear with your basics, you can solve even hard questions. That is something that I want to show with this particular video. Because often that was all for this particular video. You can consider this question as this question to be in the level where you can see this particular level of this question is something that you can expect in a FAANG level interview. Okay, FAANG interview. So often that was all for today's video, and yep, please keep it up. Today was the second last day. Tomorrow will be the last day for January daily lead code challenge. So really big congratulations to all of you who have maintained their pace till now. This challenge was not easy. There were so many good level questions, but if you have been consistent, a big congratulations to all of you. And even today I completed 100 consecutive days in lead code. It was definitely a tough milestone, but I'm very like feeling good that I made it through this, and like you all have been part of my journey. So thank you to all of you for being with me, for giving, so being my motivation. See, all what we need is, we need a community to go further. Okay, that's what I'm trying to build through this particular YouTube channel. So if you want to share something, if you want to learn something, please be part of this community. Please speak openly. Please share your ideas. Please speak up about your doubts so that we can all help you. Okay, maybe someone else knows better, they can comment out, or someone else has a doubt, they can comment out. So it will be like a community for all of us. So yep, that was all for today. I completed 100 days, and yeah, we are also just one day away from completing January daily LeetCode challenge. See you tomorrow. Thanks a lot. Please subscribe if you like the quality.